everyone, and welcome back to Dev Shop. My name is Sherry Liz.
And I'm Rasmus. Welcome to this 19th episode of Dev Show, as Sherry said. And today we're going to talk about building green progressive web apps. So that's going to be exciting, Sherry.
Yeah, this is a pretty amazing topic, and I would say that both of us have a lot of interest in this topic. So, can you tell us a little bit more about what is it we are going to learn today?
Yeah, definitely. So all in the audience, I have been told will learn about how to influence the energy consumption within the progressive web apps, and also by that, of course, participate to the global efforts of reducing our carbon footprint. So isn't that amazing, right? Everybody would love to do that, at least, and also especially in these days, right? We will also be shown by the speaker today on the various hardware elements for the PWAs and how they're impacting, right? So it both the screen, the CPU, the GPU, the network. So really going into the different areas there, and then also how to better control the energy spent on those various elements via some of the ideas on optimizing their usage. And then he's also going to use a Wattmeter or voltmeter, or what we just spoke about before, what we should call it, but how to measure how much energy is consumed to really influence it all. So it's going to be interesting. And I mean, everybody would like to learn about how to lower the carbon footprint in the world, right? So
Yeah,
look forward to
that,
that.
that's true. So, before actually you introduce the speaker, I wanted to kind of that to tell you all that our speaker is also going to stay longer after his talk to answer all of your questions. So please remember to type your question in the chat button, and doesn't matter if you're watching us from Twitch, Facebook, YouTube. Just type your question. We are going to highlight them, and hopefully you're going to get your answers there. And then while engaging with each other in the chat, and also typing your question, maybe even answer each other, I want to emphasize all of you to familiarize yourself with our code of conduct, which is listed on our main meetup page. And as usual, we want to have your feedback, and we are going to highlight our feedback link during the session. And also, all of you are going to get your Azure Heroes Learner badge as well. So, with that, I guess I personally want to start the, the session as soon as possible. So, who is our speaker for today?
Yeah, so we are so super lucky to have David joining us today. So David is a senior program manager within Microsoft. He's working closely with the Eds team. Hi, David. He's
Hello.
leading PWA Builder. That's an open source project for developers turning quickly in their websites into PWAs. And then he's also a co-author of Babylon JS. Sherry, I know that you know a bit about Babylon JS. You've also spoken about that. So I would like, yeah, either you
Yeah,
or
it was
David to kind of talk
almost
about that.
last year by this time. I gave my very first talk about Babylon JS in NGBE. Yes.
Congratulations.
Yeah. So welcome to the Dev Show, David. And
Thank you so much for inviting me, and let's try to share some fun content. Like, yeah, it's a serious topic, but I've got some fun content. Let's hope so.
Yes.
yeah,
So let's get it started then. Stage is yours, David.
Thank you.
take
Thank
it
you so
away.
much. So you should be able to see my slide. So thank you. Welcome to this session. So I've been using the word green, even if it could have various, meaning. The global idea of this session is to see together why progressive web app, PWAs, and web apps in general, to be honest, are super important today, and why maybe as web developer, we should pay attention to the energy consumption of our web app. So you can follow me on Twitter if you like to. And the agenda will be why should we matter about the energy consumption of our PWAs, and what are the various parts where we're going to consume some energy. Today we're going to focus ourselves on the client part of a PWA. Then we will see the various devices executing our web code, and check on these specific devices what are the main source of energy consumption regarding the components. To be able then to know what we are doing with the code, we need some specific tools, some tooling to help us to measure this energy and to check if what we are doing is going to improve or not the energy consumption. At last, I've got a bunch of benchmarks. I really love doing benchmark, as Shay has been sharing at the beginning, and I've been doing Babylon.js, so I've been doing a lot of time doing profiling to check that the code is working fast enough. So this is something I really like doing, and it's really helpful to help you making the right decision. At the end, I've got some idea I like to share for the future. I start to have some of the answer to those ideas, and maybe you'll be able to ask your question there. So why should we bother about PWAs? So web apps are everywhere all the time. What we've seen during a recent event, our CEO Satya has been sharing during one of his talks that 60% of the time spent by a Windows user is inside the browser itself, meaning that it's something that the user is going to spend a lot of time into, and browser are the place where your code is going to be executed. So it means that you could have a lot of impact by tuning your code for energy consumption. There's three main sources of energy for your PWA. The first one is the hosting, of course, meaning where you're going to put your code on a specific server based on where it is located. It could already have some impact. So we're going to see that you could do a choice just at this specific moment. Then, of course, the data and the code need to be transported from the web server to the client machine using the network infrastructure. Once again, like using all those hardware to be able to transfer the data is going to cost some energy. It's more difficult to evaluate for you as a web developer, but some people have some model to help you evaluating that. And at last, and this is where we're going to spend most of the time, if not all the time, is on the client side. And this is where I'm spending most of my time as a developer at Microsoft today, and this is where I wanted to check if we could do something. But first, talking about the hosting, I don't know if you know this website. If you go on electricitymap.org, you can have a look to the type of energy being produced, the way we are producing energy in the various countries. So some countries are really good being super green, let's say, like the Nordic country, thanks to the natural resources they have to produce renewable energy. In France, we have a good also approach thanks to nuclear electricity. Regarding carbon emission, we know that, of course, nuclear waste is not really great. But regarding the carbon footprint, the nuclear, the way to produce energy with nuclear is the probably not the better, but the less worse, I would say, way of producing electricity compared to other sources of electricity that are not renewable, like in the Nordic country. So looking at this map, it means that, let's say I want to serve some customers that are globally are based around France, maybe in UK, in Spain, and Germany. It's better to host the server in France rather than in Germany regarding carbon emission. So it's really interesting to just think for yourself, think about that where to host your data. Of course, let's say that then the customer are based in Russia. The cost of the network infrastructure will probably boost the energy consumption and will start to lower down the interest of being in France. Plus, the UX experience would be lower because of the latency. So think about that. The PWAs are more and more used on desktops. Microsoft is betting a lot on PWAs for upcoming OSs and devices. I'm working on PWA Builder, like it's been shared, and a lot of people are interested about using PWAs to also ship on mobile, because you will have one code base. You will be able to update the code on the server and it will be immediately available even in the stores, thanks to the web approach about using a web server. On smartphone, to be honest, people are spending most of their time in apps, so either native apps, sometimes some PWA being pushed on the store, but most of the time it's native apps. Still, it's getting more and more popular. But as shared, like 16% of the time is spent inside a browser. As it's more and more close to native apps, I wanted to check if we could do something, and specifically regarding the service worker. So if you don't know what a service worker is, it's a small piece of JavaScript, like it's a proxy between your page and the server, living on the client. So it's a worker. It's like running on an independent thread as a main JavaScript thread. And it helps you to retune and fine-tune the way to manage the cache and enable full offline experience, like native application. And also, if you are good enough, you could also optimize the request to lower down the quantity and the frequency of network requests. And I wanted to evaluate if it was interesting to lower down the carbon emission. But before going into PWAs and web apps, let's first analyze what are the devices where your code is running. So this is a movie I really like. I don't know if you know this movie, The Usual Suspects. And we have various suspects. I had various suspects. So what I'm going to share is the story of my own researches and the way I've been going through it. So the first question I asked myself was, well, I guess the CPU is probably consuming a lot of energy. I know GPU, because I've been working a lot with this close friend doing 3D, is consuming a lot of energy, but not always. It could be a good friend too. Network, obviously. Sensors, I didn't know if they were consuming energy. And screen. And if you know the movie, you know where is the bad guy. Let's start on desktop. So rather PC and Mac, it's most of the time the same architecture. So based on the CPU you're going to use, if it's an i3 or i7 or i9, the consumption of the energy will vary from 55 to up to 150 watts. So if you had an high-end PC like the PC I'm currently using, it's going to consume much more energy than obviously a laptop. Which means, and we will talk about that later on, maybe that's for some specific tasks you're doing in your everyday life. Maybe you should use more often the laptop when you don't need a lot of power running at the desktop PC, because it's going to consume less energy. And obviously, like AMD or Intel are similar. Regarding the motherboard, if you got like a low-end motherboard, like a normal one, it will consume from 25 to 30 watts. If you got like a gaming motherboard, once again, like the motherboard I'm currently using, it could go up to 80 watts, because you have more component on it. The way to manage the power is different. It's going to consume more power to be able to do some stuff like overclocking. But the motherboard is including like Wi-Fi, sound card, and Wi-Fi and network connection is something we are interested into. We cannot really control that as a web developer, but we can measure at least the impact of our code on like the network card. This is something really interesting. So I don't know if you knew about that, but the RAM is not consuming a lot of energy, so from 2 to 5 watts. And whatever the number of slicks of RAM you've got, like if you got 8 gigabytes of memory compared to like 2 of 32 megabytes of memory, much more memory, you're going to consume the same amount of energy. So it sounds like, and this is going to be confirmed later on by some study I've seen on mobile, that lowering down the memory consumption is not going to have an impact of the energy consumption. It's not to say that this is not really important to pay attention to memory, because let's say that you fill the complete memory of your device, it's then going to start to swap to the disk, and then you're going to consume more CPU and more IOs. But let's say that you're still in the comfort zone. Trying to over-optimize memory is not something that interesting regarding carbon emission. Well, one of the bad guy is the GPU for sure. So if you have an integrated GPU, it could be very, very low in the energy being spent. If you have like a low-end graphic card, it will be between like 25 up to 86 watts. But if you have a look to the picture on the right, like the RTX 3090, this beast could consume up to 350 watts, meaning that when you're going to play to a video game like 4K and ray tracing and all the stuff being enabled, you're going to consume a lot of energy. Regarding web, it means like when you're going to use WebGL, like using Babylon.js, FreeJS, or other framework doing WebGL, you're going to consume potentially a lot of energy because you're going to ask the GPU to work for you. Regarding hard drive, we knew that SSD really helped to having better battery life, simply because it's going to consume less energy than regular hard drive. Still, if you remember the various numbers, like IOS doesn't seem to be something really impactful on energy consumption compared to the CPU number we've seen, the GPU, or even the motherboard. IO is not that interesting. So just to tell you that something, most of the time, performance and energy consumption are really tied, obviously, but not always. And we're going to see that in the benchmark section. Well, the screen. So this is the screen I've got in front of me for right now. It's not green at all. It's going to consume up to more than 100 watts. Obviously, the bigger the screen is, the more energy is going to consume, but not always. If you have a look, for instance, to this 24-inch monitor, I don't know why it's going to consume more energy than my 49-inch monitor. So the screen, we're going to see that if you can have some impact as a web developer on it, and sometimes yes, that's why it's interesting. Switching to more mobile devices like smartphones or tablets, let's first analyze this slide. And it was really key for me to understand what this slide means. It's going to compare the energy being consumed between airplane mode, so no connectivity at all, 2G, 3G, and Wi-Fi. And the first, assumption you could make that would be wrong. So does it mean that Wi-Fi is not as good as 3G to do like network requests? Well, when you're going to do peak measurement of the energy, Wi-Fi during this peak moment will consume more energy, but Wi-Fi is going much faster than 3G, meaning that I will be able to, let's say, download 10 megabytes of data like images, CSS, HTML in a much faster way, that even if I'm consuming during a brief moment more energy like 3G, globally I'm more efficient because it's not the energy you're consuming in a peak way, but during like the total lifetime of the request. So this is something you need to pay attention to. It's not because when you will use this kind of device, like a Powermeter, that you see a higher number, it means that you are less efficient. Regarding sensors, so like I shared at the beginning, I wanted to know if sensors were interesting to try to optimize. For instance, some API could be tuned to be less frequently called. Like if I like to know the right position of my smartphone, maybe I don't need to have like an update every millisecond. Maybe every 5 milliseconds could be enough for the job I'm doing in my web app. It turns out that the energy consumed is so low that this is not an interesting candidate to optimize, because you will save much more energy spending your bandwidth and your time on other parts of your web app. So sensors, if you're using them, don't bother about trying to optimize this part. It's going to consume really a small amount of energy. And this is really the bad guy. So as guests, we see that the CPU is consuming some energy. The GPU is consuming also some energy, sometimes much more than the CPU. We see that Wi-Fi finally is consuming most of the time less energy, globally less energy than the cellular connection. And the LCD, well, the LCD panel itself is not going to consume a lot of energy. It's a backlight. The backlight is going to consume a real huge amount of energy. That's why today on smartphone, you've got, smart way of dynamically reducing the backlight based on, the external light. We've got some sensors to measure that. Because if you would put the backlight always at the maximum level, the battery will really die super fast. So this is really where we need to pay attention. And during my researches, this specific slide really made me mad. Like, what I've discovered reading this slide is that the blue light is consuming more energy than the green light, and the green light is consuming more energy than the red light. And I was, well, this could be something super interesting. Like, let's say that we remove all blue color from the CSS design of our website. Like, let's make everything red. Maybe it sounds stupid, but maybe it could be interesting to measure the impact of such design. I wanted to measure that. And first, I was asking myself, and maybe you ask also yourself the question, why blue energy is consuming more energy than red? Because of this guy is named Planck. So he's been creating this equation, so this rule, and it's the energy being consumed by a photon, and it's inversely proportional of the wavelengths. So that's why even if the blue energy got a shorter wavelength, going to consume more energy than red light. So the question is it useful? And the answer from our good friend Einstein is no. So we are in the rule of quantum mechanics. I'm also a huge fan of quantum computing, so I'm sometimes doing conferences on that. And it was fun that during a talk on web technology, I ended up on the quantum mechanics laws. So let's do a benchmark, a first quick benchmark. I've been creating 2 pages, the very same one, except that I will put a full background color with blue and red, and I will do a black one too. And I've been measuring the energy on the smartphone I've got there, a Samsung, which got a Samsung Android phone, which got an OLED screen. So using my Wattmeter, it's also named Powercfg.exe. It's interesting to see that I've managed really to save some energy, like comparing a full blue web page that is consuming between 1.3, 1.4 watts. The red screen is consuming a bit less energy, and the black screen even less energy. And it's really because OLED screens are really working in a specific way. You don't have backlight, so it means that every pixel is going to emit its own light. So when I'm going to put a full black screen, I'm going really to completely shut down the screen. So let's try to measure that now on a more regular laptop. So I've got a Surface Laptop 2. Let's measure that. And it was interesting to see that regarding LCD screen this time, as we've got backlight, you remember in the screen before, in the slide before, I was showing like this big amount of energy being consumed by backlight. Even if we are displaying like black screen, on the LCD screen, you never have full blacks because you always have backlight more or less enabled. And that's why comparing blue pages to red or black, it doesn't going to change anything on LCD screen. It's really small, the difference. You won't be able to remeasure it. I wanted then to check if creating, dark theme compared to light theme could be interesting. On website, it tends to be more and more popular. It turned out that you can save some energy on OLED screen, at least implementing a dark theme on your website. So this is a website of a gaming influencer in France I really like, and he's got this kind of, you can switch from light to dark. And doing that, I've been able to save a bit of energy on my smartphone. As soon as you start to use the web page and scroll on it, the energy being consumed is going to be really similar, or if not identical. Once again, on my Surface Laptop 2 with a LCD screen, no change at all. So what this means, so this is extracted from a research that I've been looking at. So it means that on OLED display, it's being dependent on the type of image you're going to display. So building a specific CSS for OLED devices is going to be useful to lower down the energy consumption, and then you're going to save some carbon emission. On LCD is not going to have a significant impact. Now let's go to video content, and there's a lot of video content being displayed in your web pages and your web app. Well, depending on the type of web app you're creating, but we often see some video content on the web. So to understand this slide, you've got two parts. On the left, this is some low quality video being benchmarked, and on the right, it's high quality video. So for instance, let's say it's 360p video and full HD video on the right. And then we're going to compare software decoding compared to hardware decoding. So software means it's being executed on the CPU, it's still being executed on hardware, but it's like in 3D engine, we are named a software 3D engine as an engine being executed on the CPU, and then hardware accelerated, a 3D engine, something being executed on the GPU. This is the same for video content. So if I'm running the decoding on the GPU, it's going to be considered as hardware accelerated. And you see that on low quality video, the difference is huge. Like I'm consuming 50 milliwatts of energy if being decoded on the GPU, and more than 400 milliwatts if it's executed on the CPU. So it means that it's going to cost a lot of energy if I'm not choosing the right codec, or if my smartphone is not supporting hardware video decoding. It's obviously even worse. The more the higher the quality is, the worse it will be for the difference of energy consumption. So now that we've seen the various devices, let's switch to the tooling you may find from hardware to software. So the easiest one and the cheapest one is probably this one. So it's a Powermeter. You can buy on Amazon for 20 euros. You just have to plug your PC, smartphone, whatever on the Powermeter, and you will have in a dynamic way the number of watts being consumed. You need to pay attention to something important. You need to full charge the battery of your device if you're using something using a battery like a laptop or a smartphone, because otherwise, obviously, this device will show you the energy being consumed to charge your battery, not only the execution of your web page. So once your battery is at 100%, you can then plug the Powermeter and then try to remove everything from the machine being executed on the machine, just one tab of your favorite browser, which could be Edge, Chrome, or Firefox, and then you're going to measure the energy of your web page. So this is something I've been doing. Something else, obviously, is the Windows Task Manager. So you can see the CPU utilization over time, but even more interesting, you can see the power usage and the tendency of your power usage. So it's something that you can already use to check for a specific tab. In the future, PWA is being installed by Edge. You will be able to have a dedicated line in the task manager. It will be seen as a native application, so it will be easier to benchmark. And you will see also the GPU percentage of utilization percentage, which is really important. If you remember, the GPU is one of the probably the worst bad guy compared even to the screen on desktop, at least. I don't know if you know that if you're pressing Shift Escape in Chrome or Edge, you will have the browser task manager that you will be able to see the memory, but we don't really care about the memory, at least for the power consumption, the CPU and the GPU memory. Lighthouse, obviously, being integrated in the DevTools. will help you to troubleshoot some performance issues on your web app or PWA, but then will help you also it will be kind of a good clue about potential bad energy consumption there. It's not always correlated, so we will see that just after that. But it's a good tool to do a first review of your web app and to check for the potential bad part of your code you need to pay attention to. Android Studio got also a nice tool. So this tool is not measuring energy with sensor. It's going to guess the energy using statistical models. Let's not use the AI for now. It's really using statistical models that have been built with true sensors on real devices. And we've been building some model out of that being then run on your software. So Android Studio can do some profiling. In the case of PWA Builder, we are building PWA for Android using TWA, Trusted Web Activity, and it's using the Chrome browser itself to execute your code, which means that I cannot attach to Android Studio to this kind of specific process. I would need to build a native application with a web view using Android Studio to be able to measure the energy consumption of my PWA. But something maybe you could consider if you have like an hybrid application today, if you'd like to measure the web part of your hybrid app, Android Studio could do it. Something really interesting being made by French people. It's a green Spector. So you've got the URL there. So it's like PWA Builder. You're going to enter the URL to your web app, and we're going to tell you if it's already a PWA or not. In the case of PWA Builder, in the case of Green Spector, they're going to run on real device this time in the cloud. Or your web app is running, and they're going to send you over email a report. So I've been running PWA Builder on it. So apparently we are doing a great job regarding energy efficiency. So I'm glad that my team is working right there. And you can start to also evaluate your model thanks to this tool. I wanted to evaluate the Get Battery API, the battery API, because I was thinking and I was discussing about my researches on Twitter, and someone told me you should consider Get Battery. Yes, this is a super great idea. And I started to do that. Let's do a first, measurement of the battery status at the beginning of my code. Let's do the same at the end, doing some differences, and I will be able to measure the energy consumed by my code. Unfortunately, the precision of the battery level is not super great. And you cannot then, really measure anything. You cannot really conclude anything. And during one of the conferences I've been doing in France, someone told me that I was a bit sad. I was complaining about that. Someone told me that this battery API has been created during the Firefox OS era, when Mozilla was trying to do a mobile OS. And they decided to not be super precise for privacy reason, to avoid doing fingerprinting. So I'm not sure how you could do fingerprinting, but I'm going to trust them for sure. And I'm currently asking to the Edge team to maybe enable more precision when you will do some benchmarking, or if you're running on localhost, for instance, because under the hood, the precision is much higher. It's just what is currently being exposed to the developers that is not super precise. But unfortunately, for now, we cannot use it. And the last one I've been using, so like Android and iPhone on Windows, we have a part when you will be able to check which applications are consuming the most of the energy for the battery. So on this screenshot, apparently I was spending most of my time in Edge, like I was sharing at the beginning, and then I was doing some Outlook. This tool is being run by Windows, and you can use it yourself too. So if you're running this tool, and you can go on this blog, and I will share I will share an article I've been writing on this blog later on. There is a procedure to help you using this tool, and you will have a specific CSV file that every minute is going to tell you which process where is being spending its energy in the network, in the screen, in the CPU, etc. And I've been using this tool for the benchmark. So let's jump into the benchmark, the most fun part of this session, but we really need to understand before jumping into the benchmark where we're spending our energy and maybe how to measure it. Let's jump into the CPU because we know this is one of the bad guys. And I wanted to measure WebAssembly because a lot of people are using WebAssembly, and we know that it could be much faster than JavaScript. And to check if it's more energy efficient than the pure JavaScript. So what I've been doing, I took a sample and I updated it to do face tracking. So using like, deep learning model. I don't remember if it's using TensorFlow or not, but I know that there is 2 versions of this demo. So I took the JavaScript one, the pure JavaScript one. And when I was measuring that with my Wattmeter, you can see that on the screenshot, I was consuming 10 watts most of the time. And I had 2 frames per second, meaning that JavaScript was obviously struggling being able to do real-time face tracking. So let's now check WebAssembly. And what do you expect from a WebAssembly? Let's ask you the question, and we're going to see the answer just after that. Do you expect it to consume the same level of energy, less energy, or more energy? And the answer is much more energy, almost double the number of energy being consumed by pure JavaScript, but with a great benefit. We are jumping from 2 frames per second up to 30 frames per second, meaning that we have to make a decision there. Do you want to have a better UX, like a better user experience, obviously, because doing a real-time face tracking at 2 frames per second is not really great. You see what I mean? So maybe we can find a trade-off between 30 frames per second and 2 frames per second. But obviously, as we are using more CPU resources, we're going to consume more energy in the benefit of the user experience. But I knew it was an edge cases, so I wanted to go further than that. So I wanted to evaluate another benchmark being done, and I've got the link at the end of the page, and I've got the link also in the article I will share you at the end. So this time I've been running the same benchmark that is simulating like office type of task, like opening a PDF, updating some text in a PDF, searching for a specific text in a PDF. And the time to be executed on pure JavaScript was 45 seconds compared to 25 seconds. So the WebAssembly is obviously much faster, which is a good sign. Using my Wattmeter, once again, I was able to see that the range of energy was lower using JavaScript from 21 to 25. But remember that this is not because I'm going to consume more energy in a peak way, that I will be less efficient. And then I was trying to do something that is really stupid, so don't do that at home, is try to, to guess an approximately average usage of energy. And to be able to really know the energy being used, I've been using Powercfg. So I've been running the benchmark, and I asked Powercfg to tell me the number of joules. So it's going to give you in millijoules the number of energy being spent by this specific process. So it was edge in my case. And you see that I've been able to save almost 100 joules on this specific amount of time, meaning that for sure, WebAssembly could be a really good friend to save some energy. Let's continue on the CPU this time. Let's try to see if web workers could be a good friend. So we know that, unfortunately, so far, JavaScript is monothreaded by nature most of the time, which means that it's a bit of a shame. Like I currently have 10 cores on this current machine with hyper-threading, meaning I could go up to 20 threads at the same time on this specific machine. If I'm using JavaScript, I will use only one of the core. So web worker have the kind of multi-threading, like but very simple version of it. And we know that most of the time it's not very easy to use it. But let's try to use web worker. So I've been using like an extreme example. Let's use a RayTracer. So RayTracer are really a good candidate to evaluate the performance gain of web workers. And you can see that there. I've been using my Surface Laptop 2, which got 4 cores with hyper-threading. So I've got up to 8 threads in parallel. And running on the normal version of JavaScript, I would say it took 31 seconds to compute an image of 4,000 by 4,000, and only 10 seconds using 8 workers. You probably know that it's not linear, the performance gain you've got. About the energy consumption using my Powermeter, once again, it was really interesting because I was consuming much more energy during the in peak during the 8 workers test, like 35 watts, which was the maximum of energy I could consume with my laptop charger for only 19 watts on the mono-threaded version, let's say. But if you look at Powercfg, that's why you should not just have a look to peak energy. I've been able to consume 3 times almost less energy using the workers. So web workers, when they are meaningful and could really save energy, you can do a lot of stuff in web workers. You cannot update the UI, but you can do network requests. You can work on your cache. You can do a lot of stuff in a separate thread in a way. Okay, video quality. And I was joking about, can blurry images save the planet? In a way, yes. So I've been using YouTube, which is a web app, one of the most famous web apps you could use today. And I've been comparing some video I've been doing myself, like in 30 frames per second first. So in the lower quality, I was consuming 11 watts. In 4K, two more watts. So you see that saving 2 watts on every machine on the planet could be really important. The GPU usage is obviously going up based on the resolution I've got. Switching to 60 frames per second, you see that you're almost consuming the same amount of energy between 30 and 50. But it's going to change when you will go up to 4K, at least on the Surface Laptop 2. And you see the GPU usage is really going up. This is using an integrated Intel GPU. This means that you should never switch the auto feature of the YouTube player, because it's going to compute what is best for your screen. And you don't need to display 4K 60 frames per second on a small smartphone screen, because it won't change anything on your visual perception. So globally also, try to avoid 4K videos. Like, a lot of people cannot make the difference between Full HD and 4K if you are far away from the screen. So if you like to save some energy and reduce the carbon footprint, don't use 4K if you don't need it, except if you're watching a great movie on your big screen. We've got also an estimation engine inside Microsoft that's going to measure every application from the store on some machine and be able to see some statistic. This is a famous streaming video app. I'm not allowed to share the name of this partner with you, but you remember during the first lockdown in Europe and worldwide, I would say, there was around March, we've seen an increase of the CPU energy. Why? Because a lot of people were spending their time watching videos inside this famous, streaming video application. And then, a lot of those streamers decided to lower down the quality of the video for the sake of the quality of the network infrastructure, to avoid congestion there. And what we have seen that even on the client part, so this is the energy spent on the client, not on the network or on the server. We've seen that we've been able to lower down the energy being spent. So it's just going to confirm once again that if you display Full HD, it's going to consume much less energy than 4K, for instance. This one is fun. So I'm doing WebGL during my spare time. Now I'm not working anymore on the Babylon.js project, but obviously I'm still using my baby when I would like to do some fun experiment. And I've been building a WebGL PWA. And have a look. So this is a video I've been doing. Have a look to the zoom level. I'm currently at 100% on my WebGL game. So I can show you my WebGL game with you if you like to. This is this one. You see, it's going to load super fast because I've got a service worker. It's a PWA, obviously. And this is a stupid game when you can just destroy some apple using either your finger on touchscreen, mouse, or in VR, using WebVR even. So it's super fun. And I wanted to evaluate the energy consumption. So obviously, as I'm using a lot of CPU, GPU, I was at the highest level of energy on my power meter. And now let's see the impact of switching the zoom level. So you should see that I'm going up to 400%, and you see the energy now is around 60 watts, even going to 500. I don't remember if I'm going to go to 500. Yes, so I'm going to lower down to 15 watts, and now I'm going to go back to 100%. And you're going to see the energy consumption that's going to go up. So it's not immediate, on the power meter. It's not super precise compared to Powercfg. But if I'm going back to 100%, you see the energy is going higher. So normally, if you ask yourself the question is why? It's because like video games, when you're going to boost the zoom level, you're going to lower down the rendering resolution of the WebGL canvas. So the GPU will have less pixels to draw. It will just have to do some upscaling to stretch the image on the real screen resolution. And this is something often being done in video games. And it's going you're going to have some blurry image if you're doing that too aggressively, obviously. But most of the time, people won't be able to see the difference and will use less energy. So think about that the next time you will play with the zoom button. Maybe you're going to save some energy by just doing that. The last one is service workers. I've been first troubleshooting, benchmarking my video game. In the case of video game, just being able to save a little bit of energy on the network stack, and I'm going to explain you why. So let's take this sample and let's execute that in private. Like I'm going to bypass the service worker doing that, or I'm going to start it from scratch. And you see that I'm currently doing the network request and I'm currently filling the cache. And this is taking a lot of time. So I wanted to check if I was able to save some energy using the service worker. If I'm comparing that, for instance, which is super long, to that, you see the difference is really obvious. And it was fun because the difference of energy, I'm saving a lot of energy, you see, as being compared on Powercfg. So Powercfg can tell you just the network stack. But what I'm saving energy because most of the energy is being spent on the spinning a logo, not about the network request. So I'm making the logo spinning really almost none using the service workers. That's why I'm saving energy, not thanks to the network. So I've been doing another experiment. This time I've been using downloading a big DRM file that I put it in offline mode using a service worker. Some experiment we are doing once again with people that would like to use PWA for their streaming app. And I've seen this time being able to save 12% of energy thanks to my service worker. So just to tell you that service worker can help you saving energy on the network. And I'm talking only a bit about the client part. Obviously, I'm going also to save energy on the server and network infrastructure part, but it's not being measured by this tool. It means that you need to design the service worker in a way to lower down the number of requests, obviously. If you are using a service worker that is just going to do some basic caching, it's not going to change the level of energy being spent on the network. So, but it could be the case. Some idea for the future. I wanted to know if it would be interesting to dynamically adjust my code based on where you're living. And I've been able to find some interesting studies that this is not that stupid. Should we build a CSS or JavaScript framework to help developer building sustainable PWAs? I'm not sure about that. I haven't been able to measure lazy loading for big images or to measure SVG compared to bitmap. Maybe SVG is lightweight on the network, but maybe it's using more the GPU. I don't know. I need to measure. And also, I would like to better use the Battery API, something I'm currently doing with the Edge team. And I've got soon a call with them to try to evaluate that. And I'd like to thank you. And I think we are open to question. I try to keep my time normally.
Thank you for the great talk. It was very informative, and especially that WebAssembly one. I was totally assuming that it should, for whatever reason, I assumed that it's going to consume less power. So for me, the rock.
That's why you always need to measure.
Yeah, and we actually we don't have question in the chat, but I have 3 questions for you.
Yep.
And so one of the thing is that as a front end developer, I mean, you showed us a lot of the greatest stuff. So if you want to start a project right now, where would you start? What are the things that that you would kind of that you would have in mind to follow to have your app kind of that as green as possible?
Well, this is an interesting question. I think we are just at the beginning of it. For sure, you need to pay attention to what I've shared, meaning that pay attention to CPU, GPU, and network. Meaning that some frameworks are sometimes super useful, but at the price of energy consumption. And in the past, it's unfortunately it's super recent that we start to pay attention to those green principles. Maybe it's going to change the mind now. Let's say that you start a project from scratch. Do you really need Angular or React or Vue? With all these complex tool chains that's going also to consume a lot of energy. And I've seen like even outside of energy consumption, I've been taking back some project that was nightmare to to update because the technical debt was super high because people really want to train themselves and have fun with great technological stack at the cost of a technical debt, but at the cost of some energy. So try to use simple technology if it makes sense. Sometimes you really need React or Angular. I don't say that those frameworks shouldn't be used. Actually, you should now ask this new question at the beginning of your architecture design and review. What's going to be the cost of the energy? And same for like accessibility. Accessibility is something you need to take into consideration at the beginning of your project. Otherwise, it's going to be super complex to integrate after the fact. I think it's the same for green principles. But once again, we are at the beginning, so it's really difficult to give precise guidelines. It's just I would like to open the mind of people that they could embed this new question at the beginning of their projects.
Mm-hmm, mm-hmm. Yes, that's true. I know that we still don't have. Oh, sorry. I guess my mic was mute. So I guess I know that we still don't have like a super secret recipe of creating the green application. That's why that there are a lot of things going on right now, and I guess as an engineer, all of us, we have to start kind of that looking around and see that what are even the biggest step that we can take, and we should have it as a responsibility. Even the it was interesting that you mentioned that the colors kind of that even important. So these are all for us food for thought to have.
I know some people are starting to evaluate also, like I was sharing that Germany is not really great for now for energy production. Some people start to geolocalize people and provide a different design for those users based on their location. So I don't know if it's in a way you're going to punish people living in Germany because they haven't made the choice, of all the energy production. So I don't know if it's really good or not. But like you said, we are all in this boat. I would say now we are web developer. We are developers, and I've been able during my research to prove to myself, and I hope to prove to other people that we can have some impact. And so we need some new patterns. So anybody should contribute to that. If you go on the sustainable blog, we have like some 8 big principles being shared there, and I'm working with Asim, who is working, on the initiative, and we would like to collect like a bunch of idea, new pattern people may find by doing their websites, and then trying to build these new approaches. That's why I was thinking on the framework maybe in the future that could help people that would be lazy but interesting in being green. We are not there yet, but we need to do some effort there, because we know that more and more energy being spent by digital stuff, like on the web or in general, and we are part of this, so we need to be a good citizen.
Yes, that's very true. And we actually had Asim as a speaker in our previous last week's
Great.
event. So in a follow-up email for all of you, I'm going to include all the links that David also mentioned, the link to the blog that he also mentioned. And if you missed Asim's talk, that's also really good to go and check out on our YouTube, and then watch that one that he has like a introduction to what David is actually is building on top in this session for you all. And Rasmus, do you have any
I
questions
see a
for him?
question from Vadim. He's asking who is hiding behind the shelf. It's an unmade C3PO, so from Star Wars. So it's being made by my grandfather a long time ago, and that's why I really enjoy it.
That's great. Yeah.
Yeah. Yeah. So no questions from my side. I just think it's great to learn that even the small things, if you have developers thinking about the small things that can contribute to the greater project of driving down the carbon emissions in the world, actually, right? So if every developer had the thinking and asking the questions that you're doing, David, then we would see all the drops being to becoming an ocean, right? So that's just my main takeaway. I think it was an interesting session. So thanks for that, David.
Thank you.
Yes.
So I
I
think
guess
that's
we.
yeah. Let's ask for, as always. We would like everybody's feedback. So both for this specific session, so we can share it with David. Also for Dev Show in general. As we also said last time, we are working on the lineup for 2021. So there's going to we need your feedback also for what do you want to see in 2021. So we have already speakers that we are putting in for the first quarter at least, but please let us know what you want to see in your show, which is the Dev Show here. So put it into the feedback form, contact Sherry and myself, use the Dev Show hashtag, or yeah,
Yeah.
any way works.
And also if you fill out our feedback form, one of you randomly is going to get some prize from us as well, as a thank you for giving us your feedback. So, and speaking of prize, so all of you, of course, you're getting the Azure Heroes Learner badge as usual. So just scan this QR code and then get your badge there. And we have more than Learner badge. Actually, one of the badges that we have that I mentioned before as well is a green developer. So if you are doing something in that area, you can also nominate yourself, or if you know someone else that is doing a great effort there, you can actually nominate that person as well. And all of the nominations to this directly go to actually Asim, who was our previous speaker, that who has a good knowledge about this one, and then is going to assessing that and make sure that the right person get that badge, because green developer badge is the most valuable badge that we have. We have only 75 of them for entire year. And you can go to this website and see that the Azure Heroes around you, and you can add yourself there if you want to as well. And upcoming event, Cosmos.
Yeah. So I was talking about we're creating the lineup for 2021, but the rest of December here, we're gonna have one more session, which is gonna be next week, and we talked a bit about it last week as well. So we're gonna have Vasim, and not Asim, but Vasim join us to see if he can actually control his coffee machine with his brain. So if you join the session, you can see if it's reality or dream. I'm looking forward to it. And then Sherry, you're also starting up a new show, which is the Mega Show. And Jim is gonna come on the show and talk about IoT powered holiday lights. So also really up in time. So holiday lights right now, right? So
Yes.
exciting there.
So you will have
But
after this session. Sorry to interrupt you. So after this session, you have one day to actually to make your holiday light more genius. So for the
yeah.
Christmas.
And I just wanted to say to check out the sessions here. Just make sure that you check out our meetup page to see when we add the sessions for 2021. You will of course also get a notification if you already signed up for the meetup, but it will come in there.
Yes. So since this is the right session for the right audience, so there is actually a climate action TEDx going on December 16th, and you can use the link aka.ms/cat-tedx. You can register for that. There's a great lineup there. That is actually a really interesting community to be part of, and they often have really good topic around generalities for the developers that they want to fix the climate issue. And then if you want to contact us, the best way is to ping us on Twitter, and both of us we have our DM open.
Yeah. So only left to say thanks to David. I can see that his camera is shut down, but there you are, David. Thanks for being on the Dev Show. Thanks for the presentation. And I guess, yeah, see you all next week. Look forward to that.
Yeah.
Thank you so much. See you.
Bye.